4.5.1 milligalloway. So firstly, we're going to be talking about data preparation. There are many words that we use when we're describing how to prep data. The first one we're going to talk about is range. Range is calculated by the largest number minus the smallest number. So in this case of our data set, if we find our largest number, it's 51, and our smallest number is 15. So you would do 51 minus 15, and that would get you your range. Range is useful as it shows the spread of the data. You can see clearly from the range whether there is a large difference or a very small difference within the data. The issue that comes with the range is that it doesn't say where the data lays in this set. For example, if there is one value of 20 and 4 values of 3 and the data set is a data set of 6, the range seems large. However, the majority of the data is collected all in one area, which is around the value of 3. This isn't represented by the range. Kalla, 2019, states that range is simply the difference between the maximum and the minimum observations. So the next word we're going to use for data preparation is rank order distribution. Rank order is another way to present data. It shows the smallest to largest figure, or vice versa. It's helpful for when you want to see the majority of the data lies, unlike range. Rank order is used generally when there are less than 20 numbers so that you don't have a really long column of data. The way to rank data is by a simple ordinal position where one variable or option is higher than the other. So on the left, you can see that the upper arm girth goes from smallest to largest, starting at 22, goes all the way up through 25, 30, 32, 35, 38. And on the opposite side, on the right hand side, you can see that 38 is the top. So we're going from highest to low, and then it goes all the way down to 22. With range, you would only see the 38 minus 22 and that value. However, here you can see that we've got two 25s, so you can see that some of the data is actually nearer the lower end of the set. The next is simple frequency distribution. It is commonly used when there are repeating figures in the data. Therefore, instead of repeatedly writing out the same data, it would be tallied. This would reduce the data into a more manageable format for the researcher as they can see the most popular option. This is often called the mode. The use of the third column, labelled cumulative frequency, allows the researcher to account for all the data and make sure that no data is missed when condensing it into smaller, simple frequency tables. This is easily done if the data isn't put into rank order first. For example, the data I've used, the skin-fold caliper test for the gymnastics, you can see that there are 3s, 5s at the top, but if you look down, there is one more. So here's the extra 5. Because it's not rank ordered, you might miss that and think there's only 3 5s, but there's actually 4, which you can see in the frequency here. Grouped frequency distribution is when the numbers are large and you have a large set of data that cannot be presented in an organised way. Therefore, the researcher may group the data and tally up the amount within that group. This condenses it into a more manageable and presentable format. This allows to show the mode but not the exact figures because the method of data preparation could be used even if there's no repeating data. So as you can see, the data is more widely spread here. So we've grouped it into 300 to 400, 400 to 500, 500 to 600, and 600 to 700. We've just tallied the frequency. However, we can no longer see where within the 300 and 400 these two values were. That is the only disadvantage. However, it does condense it into a much smaller format, which could be more manageable for a researcher. So we're moving on to data presentation. There are many ways that data can be presented in order to display data in a visual way. So as above, in the data preparation section, you can see that we put them in tables. If we hadn't have done that, they would have just been a long line of numbers, which is really not what we want to see. So we would put it into different formats like columns, graphs, and tables. So the first way of presenting data that I'm going to talk about is a scatter plot. The scatter plot graph shows where a value is in relation to another value. Above you can see my example using resting blood pressure, diastolic and systolic. This allows the researcher to see the relationship between the two values. Above you can see there is a very weak positive correlation showing that diastolic blood pressure is higher, so is systolic blood pressure. However, there are points on the graph that go against this correlation, making the correlation weak, but it still shows the researcher a relationship. Scatter plots, although show relationship, are not good when there are multiple variables that the relationships are between, as when there are more than two axes, scatter plots can become confusing and lose correlations amongst the different variables. Next is line graphs. Line graphs are used to show changes over time. They are useful when there is more than one variable you are trying to track. For example, above there are systolic and diastolic blood pressure changes. It is easy to compare and catch trends in this graph, instead of reading it in a table of values. However, line graphs track changes over time that actually make my graph above confusing because the x-axis in this graph represents the participants and not time, therefore making this graph less helpful than the scatter plot graph shown on the slide prior. As this doesn't particularly show that the diastolic blood pressure is high when the systolic blood pressure is high, you can only see this when you look at the peaks and where the top line is high, parallel to that the bottom line is high. So if we look at the peaks here, we've got a peak up here and a peak down here. This does show that when diastolic is high, systolic is high, but it doesn't show it as clearly as on the scatter plot graph. Histograms show frequency. This is different to line graphs which show changes over time and scatter plots that show relationship. As above, the frequency shows that the majority of female gymnasts in the sit and reach come between 23 and 36 centimeters. The next majority of the players were in the category of 36 to 50, and then the following with the least amount were the 50 to 60 category. Histograms are great to use when there is a large volume of data that would take a large amount of time to plot on a scatter plot, and with large volumes of data, scatter plots can become overcrowded, meaning that they are hard to interpret and they may not show a correlation. However, histograms don't show where the data lays within the bracket. Therefore, there may only be one participant at 22, but the other 8 are at 34 plus, meaning that the histogram doesn't accurately represent all the data in the data set. Tables. Tables are another form of presenting data. The data in tables are often nominal data, where the data falls under categories that are unrelated and the table marks down the frequency. Tables convert raw data into something more organised and presentable so that the researcher can see exactly what they need to see. For example, the raw data for the table above was organised participant A to M. However, this table is organised so that the data is ordinal. Therefore, in the rank, this allows the researcher to see if there are any correlation between the two data sets, such as participant 1 came 8, participant I came 8 in both standing vertical jump and resting heart rate. This table also allows the researcher to gain information such as the mean and the standard deviation that can be added to the bottom of the table to give extra information and more depth that you wouldn't gain if the data was in a graph such as a scatter plot. However, with lots of data, tables can become big and substantial, and then you cannot find relationships and trends within the table, whereas if you had a big scatter plot you would still be able to see that. Bar graphs are a way of showing frequency data. For example, above you can see the skin fold caliper results for my gymnasts. In fact, this chart is so accessible to this data that it allows the researcher to put more than one variable in the chart. This shows the bicep and tricep results of the participants. This is good for comparing the results participant to participant. For example, the researcher can compare two athletes. Athlete 10 had high levels in the skin fold caliper in comparison to athlete 11 who had very low results in the skin fold caliper. So as you can see, 10 had this huge bar and 11 had a very small bar. The box plot is a useful way of presenting data as it shows the spread of data. The two whiskers show the range in the data. So there's the whiskers here. The range is between. The middle of the box plot is where this line is the median. Median is the middle value in the data set. The box shows the interquartile range. The interquartile range is the middle 50% of the data. The upper quarter and the lower quarter are also shown in the box plot between the whiskers. The range is often hard to identify on graphs such as the bar graph, like on the slide before. Therefore, the box and whisker graph, or the box plot, as I call it, are more suitable to finding the range. Above is the normal distribution curve. If data is normally distributed, when the data is plotted on a graph, it should make a shape that looks like a curve, like this. Goes up and goes back down and curves. The normal distribution curve tells us many things. The mean value of the data set is the highest point on the curve. So here would be the mean, here would be the mean, and here would be the mean. If the normal distribution curve is very pointy and high, this means that all of the data was very close together when collected, and we're all quite close to the mean. If the curve is very flat, then the data is widely ranged. For example, the yellow one on the diagram. So here's the yellow one, it's flat, which means the data was widely collected, so there's lots of range within the data, whereas this blue one with a high pointy top means that the data was very close together. There was not a lot of range. The curve itself attains about 68% of the data collected. Therefore, you can confirm that the majority of the data in the blue curve is close to the mean. However, in the yellow curve, you would say that the data is spread far away from the mean. Another form of normal distribution curve is when you get positive and negative skews, which means when the mean is not in the middle of the data set, which means you'd have more either positive or more negative. Finally, there are outliers. Outliers are points that don't quite fit with the data. As you can see above, the circle point at the top is an outlier. It goes against the trend of the other data. There are two ways that a researcher can deal with outliers. They can use Winsorizing, which sounds complicated but actually isn't. It's when you give an outlier a value that would fit with the data. For example, above, the outlier value on the y-axis is 185. The researcher would simply change this value to 100, bringing it down to here, so that it fits the data trend. This is Winsorizing. And the other option is trimming. Trimming is simple. It's when you disregard the data completely. It's simply taken out of the data set and ignored, so that point would just not be there. For the third section of this assignment, we're moving on to descriptive statistics. In this section, we're going to talk about the three types of central tendency. Central tendency is a way of describing statistics. You would use these words to show what you have found instead of looking at a load of raw data that would be unmanageable. So the three types of central tendency are mean, median, and mode. Some of these I've explained briefly before. So the first way of describing statistics is using the mean. The mean is all the data added together and then divided by how much you've got. I have done a worked example above. On the left is the raw data collected by the gymnasts. In the next column, the raw data has been added and then totaled at the bottom, which is 518. Then I need to divide it by 14 because there are 14 participants. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. 14 participants there. So I then did that calculation, which gave me 37. 37 is therefore the mean. So, the median. The median is the middle number of the data set. However, the issue with the median is it disregards the values of the data and it only focuses on the position. For example, there may be a data set that is 1, 1, 1, 1, 1, 9, 1, 4, 1, 4, 1, 4, 1, 4, 1, 9. However, the median would be the number 9. Although this was only mentioned twice, it was in the middle. So above, I'm looking at my sit and reach data from the gymnasts. My median score, so here is all my scores. My median score is the middle score, so if I've got 14 scores, it's the 7th score, which in this case is 41. So 41 is my median through my worked example. The mode is the most common value, therefore the value that the majority of the participants above answered. As you can see, the mode of this data set was 74. So here's all my data, 83, 68, 55, 90, 72, 65, 74, 92, 50, and 63. 4 people said 74, or got 74 even in their score, sorry. Whereas all the rest were 1 other than 68 with 2. So that was resting heart rate, that would become the mode, 74. In conclusion, I believe all 3 of the central tendencies help describe the data that's been collected, but if you use one of them on their own, they can be misleading. So although the mode is what most people had, there is still quite a range in the data, so we've still got 90 here,